So, now we have to do potential due to a system of charges. Suppose there are Q1, Q2 and Q1 are the charges which have got position vectors R1, R2 and Rn relative to some origin. So, we can take suppose the charge Q1 over here, Q2 over here, Q3 over here, and you have to get electric potential at this point here. Here this and this. This distance we can take R1p, this we can take 2p and this we can take R3p. So, potential at point P due to all these three charges, there are n number of charges, suppose system is containing n number of the charges. So, due to this first charge we can write V1 is equal to Q1 divided by 4 pi epsilon naught R1p. Similarly, we can write V2 is equal to Q2 divided by 4 pi epsilon naught R2p. R2p is the distance between the point P and the charge Q2. So, now the total potential at any point P due to n number of the charges is actually equal to sum of the potential due to individual charges. So, the total potential at a point P can be written V is equal to V1 plus V2 plus Vn, that can be written V is equal to 1 upon 4 pi epsilon naught, it is here Q1 upon R1p plus Q2 upon R2p plus Qn upon Rnp, if it has got n number of the charges in the system. Now, if there is a continuous distribution of the charge, then we have to take charge density and we have to get potential due to a small amount, a small element of the body, and then you have to add it. Suppose you have got any spherical shell like this. It has got the positive charge over here on its surface here. Then positive charge is Q, radius is R, then at any point over here at a distance R, V will be equal to Q upon 4 pi epsilon naught R. This is the R is the distance here from this center to this point. It means outside, if R is much greater than the radius, so for this point this shell is behaving as all the charges of the shell are concentrated at the point O, and the total potential at this point is given Q upon 4 pi epsilon naught R. If you are getting it on the surface, so we have to replace R by small r by capital R, and we will be getting Q upon 4 pi epsilon naught R here. And now see here, the potential at any point is actually defined as the amount of work done in moving the charge, unit charge. So, see here, now inside the shell if you go, you will find there is no electric field. So, inside the shell electric field is equal to 0. It means when the charge is moved inside the shell, there no work is required to be done. It means the potential at every point inside the shell remains same, that is a constant, that is equal to V equal to Q upon 4 pi epsilon naught R. So, inside the shell electric field is 0, but potential remains same everywhere, that is this much. It is not equal to actually 0 because no work is done in moving the charge from one point to other inside the shell.